Take a second and look in the mirror. If green is looking back at you, you're carrying one of the rarest traits anywhere on Earth. Rarer than left-handedness, rarer than red hair. Pass 100 people on the street, and only about 2 of them will have what you've got. For most of human history, there was no real answer for why. People pointed to witchcraft, to royal bloodlines, to cursed marriages, anything except the actual reason. But scientists have finally dug it out of the DNA, and the trail doesn't go where you'd guess. It runs older and stranger than expected, all the way across Asia. Before we get into it, if you've got green eyes or you know someone who does, do me a favor and hit subscribe. This channel is built around digging up the hidden history hiding in your DNA, the stuff no ancestry test will ever tell you. There's plenty more of this coming. Now, let's get into where green eyes really come from. First, let's talk about just how rare they are, because the numbers are wild. Brown eyes cover most of the planet, around 3/4 of everyone, and even higher in some places. Blue eyes are the well-known minority, common up in Northern Europe and scattered thin elsewhere. Green, though, is in a league of its own. Estimates put it at around 2% of people worldwide. 2 in 100. In some countries, you could walk through an entire city and never spot a single green-eyed person. That scarcity is exactly why the myths never stopped coming. When something's rare enough, people give up trying to explain it and start inventing stories instead. And invent, they did. Across history, green eyes were painted as something otherworldly, usually in an unflattering light. In parts of medieval Europe, a green-eyed woman could be branded a witch just for being unusual. Elsewhere, the color got linked to jealousy and envy, which is exactly why we still say someone's green with envy or call jealousy the green-eyed monster. Travelers described green-eyed strangers as though they belonged to an entirely different species. For thousands of years, that was the best explanation anyone could offer. When you can't explain something, you dress it up in fear and folklore instead. It took modern genetics to strip all of that away and swap the superstition for something far more remarkable than any legend. It also helps to know where green eyes actually cluster, because they're not spread evenly across the map at all. The heaviest concentrations on Earth show up in the north and west of Europe. In Ireland and Scotland, green eyes are dramatically more common than the global average, with a huge chunk of the population carrying them. Move across the rest of Europe and the numbers gradually taper off, and by the time you reach East Asia, Africa, or the Americas, green eyes become almost non-existent. That uneven spread isn't random. It's a direct trail marking where the ancient light eye mutation traveled, took hold, and mixed with every population it encountered. Eye color, it turns out, is a quiet map of human migration written across billions of faces. Here's the first thing that's going to mess with your head. Your green eyes aren't actually green. There's no green pigment anywhere in the human eye. None. Not a single molecule of it. Grind down a green iris and study the chemistry, and you'll never find a green dye hiding inside. So how are you seeing green right now? The answer is one of the strangest tricks in all of human biology, and once you understand it, you'll never look at your own reflection quite the same way again. It all comes down to a substance called melanin. Melanin is the pigment responsible for coloring your skin, your hair, and the front layer of your iris, and it only really comes in shades of brown and black. That's the whole palette. A lot of melanin in the iris gives you dark brown eyes. A bit less, and you drift toward hazel and amber. And when there's very little melanin at all, something else entirely takes over. Light entering the eye scatters off the tissue itself, and the shorter blue wavelengths bounce back out towards you. It's the same reason the sky looks blue even though the air itself isn't painted that color. The color isn't a pigment at all. It's physics, light behaving in a very specific way inside a very specific structure. Sit with that for a second because it's genuinely strange. The front of your iris is a translucent tissue, almost like a sheet of frosted glass, and behind that visible color sits a darker backing layer. When light pours into your eye, it passes through that cloudy front layer and scatters as it goes. The longer wavelengths, the reds and warm yellows, slip through and get absorbed by the darker layer behind. But the shorter blue wavelengths bounce straight back out toward whoever is looking at you. So a blue-eyed person isn't showing you a blue substance at all. They're showing you scattered light, the exact same trick of physics that paints the daytime sky. Every blue eye and every green eye on the planet is, in a very real sense, carrying around a tiny fragment of the sky. That scattering effect is what produces blue eyes. So where does green fit in? Green is the middle ground. It shows up when you get that same blue scattering effect, but with a thin extra layer of a yellowish pigment called lipochrome sitting on top of it. Blue light from the scattering, mixed with a soft wash of golden yellow from the lipochrome, and your brain blends the two together into green. You're essentially looking at a living optical illusion, a trace of yellow, a scatter of blue, and a very specific narrow amount of melanin that has to land in an exact window. Too much melanin and you'd be brown. Too little and you'd be pure blue. Green only shows up when everything lines up almost perfectly, which is a big part of why it's so rare. Nature has to thread a needle to make it happen. And here's the crucial difference between green and blue that almost nobody understands. Blue is simple. Strip away enough melanin, let the scattering take over, and you get blue. It's practically the default outcome of very low pigment. Green demands a lot more. It needs that same low pigment level. But it also needs that precise dusting of golden lipochrome, and it needs the melanin to land at an exact halfway point instead of dropping all the way to nothing. That's why blue eyes can dominate entire nations while green eyes stay stubbornly rare even in the places where they're most common. Blue is a single ingredient. Green is a full recipe, and it has to be followed almost exactly every time, or you end up with something else entirely, which brings us to the real question. If green eyes are just this delicate combination of light and pigment, why do some people have them and most people don't? What actually decides it? The answer is written into your DNA, on a stretch of code most people have never even heard of. And this is where the story gets genuinely wild. Buried inside your chromosomes is a region scientists have studied obsessively for the past 2 decades. 2 genes do most of the heavy lifting here. The first is called OCA2, and you can think of it as the melanin factory. OCA2 helps determine how much pigment your body pumps into the iris. The second gene is called HERK2, and this one is the real key. HERK2 doesn't produce pigment itself. Instead, it acts like a control switch sitting right beside OCA2, turning the melanin factory up or down. A tiny change in HERK2 can quietly dial the whole system back, telling your body to produce less pigment than it normally would. And when researchers went hunting for the origin of light-colored eyes, this switch is exactly what they found. To appreciate how strange that discovery really was, picture what these scientists were actually doing. They were reading through genetic code letter by letter, hunting for the one spot where light-eyed people differed from dark-eyed people. The human genome runs billions of letters long, an almost unimaginably vast instruction manual. And yet when they finally zeroed in on the region controlling eye color, the difference came down to a change so small you could miss it in a blink. One tiny tweak in the code sitting right in the switch that governs the melanin factory. Dialing the pigment down just enough to change how a person's eyes catch the light. Here's where it gets almost unbelievable. A team of geneticists in Copenhagen spent years comparing the DNA of light-eyed people from wildly different corners of the world, people separated by thousands of miles and thousands of years, and they found something that stopped them cold. Nearly every one of these people carried the exact same tiny genetic switch, in the exact same spot, altered in the exact same way. Not similar changes, the same one down to the same letter of DNA. And there's really only one explanation for that. Every single one of them inherited it from the same person. One individual, one ancestor who lived long before recorded history, whose DNA quietly stamped itself onto their descendants and never let go. Sit with that for a moment. If your eyes are light-colored, you're almost certainly carrying a mutation that traces back to one single human being. Someone who lived roughly 6 to 10,000 years ago, most likely near the shores of the Black Sea in the borderlands where Eastern Europe meets Asia. This person wasn't royalty. There were no kings back then, no thrones, no empires, just farmers and herders scratching out a living from the earth. But one of them was born with a small glitch in the melanin switch, an error that softened the pigment in their eyes. And instead of disappearing, that error spread. It rode down through the generations, across continents, through wars and migrations and famines, all the way to the face staring back at you in the mirror. This isn't a loose guess or a poetic stretch. It's the cold logic of the DNA itself. When a genetic change pops up independently in many different places, it usually looks slightly different each time, because random mutations almost never land on the exact same spot in the exact same way twice. But when the change is identical everywhere you look, right down to the individual letter of code, the only sensible conclusion is that it happened once and was passed down to everyone who now carries it. That's the fingerprint of a single common ancestor. One person, one moment, one small copying error in the machinery of life, echoing across 10,000 years and hundreds of generations until it reached you. We'll never know that person's name. We'll never know if they were a man or a woman, admired or feared for looking different. They left behind no monument, no writing, nothing at all except a whisper in the genetic code that outlived every empire that came after them. But every time a green-eyed or blue-eyed baby opens its eyes for the first time, that ancient stranger gets remembered in the only way that truly lasts, not in stone, but in living tissue. That's a kind of immortality most kings never managed to buy, handed for free to a nameless farmer who probably never traveled more than a few miles from where they were born. Blue eyes are the simpler version of this story, since blue mostly comes down to that one switch. Green is a bit more complicated and honestly a lot more interesting. Green eyes need that same drop in melanin, but they also need the extra players, the specific amount of pigment, the lipochrome layer, several genes fine-tuning things together at once. So green didn't appear out of nowhere. It grew out of that same ancient light eye mutation, then got shaped further as populations mixed and moved and adapted to new lands. In a way, green eyes are a record of movement. What happens when that original Black Sea mutation traveled far from home and met new genetics along the way? And where did that road lead? East, deep into Asia. But before we follow it, we need to answer something that's puzzled scientists for decades. Why did this mutation survive at all? A change that reduces pigment doesn't obviously help you survive. It doesn't make you faster, stronger, or better at finding food. In pure survival terms, light eyes should have been a footnote, a rare quirk that fizzled out. Instead, it exploded across an entire hemisphere. So what kept it alive? There are a couple of leading theories, and they might both be true at once. The first is sunlight. As humans migrated north and east into regions with weaker sun and long, dark winters, lighter features may have traveled together with lighter skin, which helps the body produce vitamin D in low-light conditions. Eye color and skin color share some of the same genetic machinery, so lighter eyes may have simply hitched a ride alongside an advantage that had nothing to do with vision itself. The second theory is more human. And honestly more fun. Rarity is attractive. In small ancient communities where nearly everyone had dark eyes, someone with striking light or green eyes would have stood out. They got noticed. They got remembered. And getting noticed has always been half the battle when it comes to passing your genes forward. Over enough generations, being memorable can become its own kind of survival advantage. The truth is probably a messy blend of both. Part biology, part desire. So now we have our origin story. A single ancestor near the Black Sea, a mutation that dimmed the pigment in the human eye, and a set of forces that kept it alive long enough to spread. Now let's follow it on a journey most people have no idea about. Because the green-eyed story doesn't stay in Europe. It heads the other way. Around 5,000 years ago, waves of herders from the steppe grasslands north of the Black Sea began moving in every direction. These were people who had tamed the horse, who lived and traveled across open plains, carrying their genetics with them like seeds scattered on the wind. Some pushed west into Europe, but others turned toward the rising sun, moving east and south into Central Asia across the land bridges that would eventually become the great trade routes of the ancient world. They carried their language, their tools, their livestock, and yes, the light-eye mutation. And as they settled among the peoples already living there, that mutation started appearing in places you'd never expect to find it. We have a fairly clear picture today of who these steppe migrants were. They were tough, mobile, and relentless, pushing into new territory generation after generation, absorbing the people they met, and steadily passing their genetics onward. Their impact on the human family tree is almost impossible to overstate. Enormous portions of the modern populations of both Europe and Asia still carry echoes of this single expansion out of the grasslands. So when that light-eye mutation spread, it didn't creep along slowly like a rumor passed between neighbors. It surged outward on horseback, carried by one of the most successful migrations in human history. Fast forward a couple thousand years, and this whole region gets threaded together by the Silk Road. This wasn't a single road, but a sprawling web of routes connecting China to the Mediterranean, running straight through the heart of Central Asia. For over 1,000 years, merchants, soldiers, pilgrims, and travelers moved back and forth along it, and wherever people trade, people mix. Genes flowed along the Silk Road just as surely as silk and spices did. Light eyes, once a quirk of the western steppe, seeped into the mountain valleys and desert oases of Asia and settled in. And in a few isolated pockets, cut off from the outside world by mountains and distance, that trait got trapped and concentrated, which is how you end up with something extraordinary. Deep in the mountains of northern Pakistan, in a remote region called the Kailash Valley, there lives a small community whose members look startlingly different from their neighbors: fair skin, light hair, and strikingly often green and blue eyes. For generations, outsiders had a favorite explanation for them. The story went that these were the lost descendants of Alexander the Great's army. Soldiers who marched east over 2,000 years ago and never went home, leaving their light-eyed bloodline behind in the mountains. It's a beautiful story, one that tour guides and travel blogs still repeat. And here's the twist. When geneticists finally tested the Kailash Dina, the romantic legend mostly fell apart. The truth turned out to be even older than Alexander. The Kailash aren't the leftovers of a Greek army. They appear to be an ancient, deeply isolated population whose ancestry split off from other groups thousands of years before Alexander was even born. Their light eyes didn't come from a handful of wandering soldiers. They came from that same deep well of ancient West Eurasian ancestry. The same stream that carried the light-eye mutation east out of the steppe long before any empire existed. In other words, their green eyes aren't a souvenir from a famous conqueror. They're a living fossil, a trait preserved in mountain isolation for so long that it outlasted the very civilizations people tried to credit it to. The legend got the drama right and the history wrong. The real story is quieter, older, and far more impressive. And the Kailash aren't alone. Travel through the mountain valleys of Central and South Asia and you'll keep finding these pockets. In the Hunza Valley in parts of Afghanistan, in the highlands of Nuristan and Chitral, green and light eyes show up far more often than anyone would expect for that part of the world. Each of these communities is a little time capsule, holding on to a genetic echo that arrived thousands of years ago and got stuck there, shielded by mountains that kept the outside world at arm's length. When you see a green-eyed child in one of these valleys, you're not looking at an anomaly. You're looking at the endpoint of one of the longest genetic journeys in human history. What makes these places so valuable to scientists is precisely how cut off they were. In a busy, well-connected region, a rare trait gets diluted. It blends into the crowd and slowly fades away. But while a community off behind mountain passes and roaring rivers have people marry mostly within the group for century after century, and a trait that arrived long ago gets locked firmly into place. It stops fading and starts concentrating instead. These isolated valleys became accidental laboratories, preserving a slice of ancient ancestry that the rest of the world blended away long ago. When researchers want to study the deep human past, communities like these are living archives. There's one face from this region the whole world already knows, even if most people never learned the science behind it. In the mid-1980s, a photographer captured the portrait of a young Afghan girl in a refugee camp, and her piercing green eyes ended up on the cover of one of the most famous magazines on Earth. That single image became one of the most recognized photographs ever taken. People were mesmerized by those eyes, and for years nobody could quite say why they hit so hard. Part of the answer is simply that green eyes are rare enough to feel almost otherworldly. But the deeper answer is the one we've been building toward this whole time. Those eyes were the visible tip of an invisible history, a mutation that began near the Black Sea, rode east across the steppe, drifted down the Silk Road, and finally surfaced in the face of a child in the mountains of Central Asia. She wasn't an exception to the story. She was the story. So let's bring this all the way back to you. If you're watching this with green eyes of your own, what does it actually mean? It means you're carrying something genuinely ancient. Somewhere in your family line, further back than any name you know, further than any photograph, further than any country that exists on a modern map, one of your ancestors picked up that original light-eyed mutation. And against staggering odds, it survived. It made it through thousands of years of chance, through countless generations where it could easily have blinked out and vanished. Every green-eyed person alive today is proof that it didn't. And here's the part that ties everything together. The part that surprises almost everyone. That mutation doesn't respect the borders we care so much about today. It doesn't care whether your family is European, Central Asian, Middle Eastern, or some blend of all three. The same tiny genetic switch shows up in a Danish fishing village and in a Pakistani mountain valley, in Turkey and in Ireland, in Afghanistan and in Scotland. Green eyes are one of the clearest reminders we have that the neat categories we use to divide people are far younger and far shallower than the DNA underneath them. Under the skin, we're all far more tangled together than we like to admit. A green-eyed woman in the Kalash Valley and a green-eyed man in rural Ireland are, in a very real and literal sense, distant cousins, both carrying a gift from the same forgotten ancestor. This is also why a simple ancestry test can feel amazing and frustrating at the same time. It might tell you that you're some blend of a handful of regions, a neat little pie chart of tidy percentages. But it rarely tells you the deeper story, the journey your traits took to reach you. Your green eyes are the perfect example. A test might flag some European ancestry and stop right there, never once mentioning that the exact same mutation is sitting in mountain villages thousands of miles to the east, or that it began with a single person on the edge of Asia long before Europe as we know it even existed. The percentages are just the surface. The real inheritance is the story buried underneath them. And that's the part almost nobody gets to hear. Now. There are a few other things worth knowing about your green eyes while we're here, because the trait comes with some interesting side effects. Because green eyes carry less melanin than brown ones, they let a bit more light through, which can make them slightly more sensitive to bright sun. That's not a flaw. It's simply the same low pigment feature that makes them beautiful showing up in a different way. There's also ongoing research into subtle links between eye color and other traits, though that science is still young. And you should be skeptical of anyone claiming your eye color determines your personality. What we can say with confidence is the deep stuff, the ancestry, the migration, the shared origin. That part is solid and honestly remarkable enough on its own. Here's one more quirk worth knowing. A lot of green-eyed people weren't actually born with green eyes at all. Plenty of babies arrive in the world with grayish or bluish eyes because the melanin in the iris simply hasn't finished developing yet. Over the first few months, and sometimes even the first couple of years of life, the pigment slowly fills in and the final color settles into place. So a baby who starts out looking blue can gradually shift toward green as that thin layer of lipochrome and pigment finishes forming. In a very real sense, you can watch this ancient recipe finish cooking on a child's face during their first years of life.